Okay, hi guys, I think I'm live now. Please do let me know if everything is good. Then we'll start today's session. Today's session is on LRDI. I would say all the sets that we are going to solve today are very relevant for CAT. They're slightly on the easier side, but definitely relevant for CAT. So I hope that you will have fun in solving all the four sets. Good afternoon, Mohammed. Good afternoon, Yeshika. Good afternoon, Samay. Good afternoon to every one of you. We have around 35-40 people who are watching the stream. Please do like the stream. This is a small thing that I ask every time because the number of likes motivates all of us who are working today. So please like the stream. If you like the stream, it will reach more people next time. And if more people join the stream, we will be motivated to conduct this kind of streams on a regular basis. So please do take a time out and like the stream. The second thing I would request you to do is please subscribe to the channel uh, because we put a lot of content. So please do subscribe to Cracku. I want to increase the number of subscriber counts for our channel on a regular basis from now till CAT. So please do subscribe to this channel and please do like the stream. We promise to hold these kind of sessions every weekend, every Sunday, every Saturday in the afternoon from 2 to 4 p.m. We conduct these kind of streams, which will be very useful for students in the run up to CAT. Let us start the session. Before starting the session, I wanted to ask you how many of you actually use the QuantRush. There are like lots of people who use QuantRush. I think till now this year we have more than 8,300 people who have used the QuantRush. This is a very popular feature in Cracku. Every single day we get like hundreds of people who are using the QuantRush. To do that, all you need to do is select the topics that you want to practice questions in. For example, if you want to practice questions from number systems and say I want to pick number systems and say geometry. Suppose for whatever reason I feel that okay, these are the two topics I want to practice questions in. Then I just click on QuantRush and then we will get questions which are based on these two topics. So for example, we have 11 factorial is, I don't know how many of you can actually see this. 11 factorial is AB9168C0. We have to calculate the value of B. So you have to figure out that okay, this is a number, that number has to be divisible by 11, that number has to be divisible by 9, that number has to be divisible by 8 and so on, and then you have to figure out the value of B. We can solve it if you have interest. Basically this C can be first calculated. This has to be a multiple of 8, so that 8 C0 has to be a multiple of 8, so C has to be I think either 0 or 4 or 8. That is the first thing. And even this number has to be a multiple of 9, so the sum of the digits has to be a multiple of 9. You can calculate the sum and then you can figure out. And it has to be a multiple of 11. You know how to calculate whether a number is a multiple of 11 or not. You have to basically sum up all the terms, all the numbers in the even places and all the numbers in the odd places, and both of them have to be either equal or both of them have to differ by a multiple of 11. So using these three values, you will figure out the value of A, B and C, and you have to mark it. I don't have any rough work to actually do it, but I don't know, I'm just going to make a guess. 5 or 8 or 1 or 9. I'm just going to guess. Okay, that was wrong, which is fine. So that was a question in number systems. Here you're going to get a question in geometry. This is basically a triangular mall ABC constructed. BC is 528. So again, you have to figure out what is the perimeter of the mall. So again, this is a question in geometry. You'll get it. You have, I think, close to 4 minutes. I think so. This was probably a tougher question. For easy questions, like in the earlier one, we have lesser time. This is probably a tougher question, so we have more time. And based on how quickly you answer it, you are going to get more marks. I'm going to again make some guess. I don't know. This also is wrong. So I have 3 lives. I wasted 2 lives in this, so I have the third life. So here I think this will be an easy question. I should solve it. X plus 2 and x plus 4 are prime numbers. What is the remainder when x is divided by 7? I think the only 3 prime numbers like that are 3, 5 and 7, because x and x plus 2 differ by 2. They are prime, so they are called twin primes. X plus 2 and x plus 4 are also prime, so they are also twin primes. So basically x has to be 3, x plus 2 is 5 and x plus 4 is 7. So this has to be 3. This will be correct. So I'm going to get some points. I got 4 points based on how I answered it. Okay, this is, again, I'm getting 4 minutes for this question. I don't know whether you can see it or not. So again, I'm assuming this is a tough question. There are 3 sides, x, y, z. X, y is 20, x, z is 20, x. Okay, the 3 sides are 20, 20 and 30. What is the length of the altitude of the side xz? I'll tell you how to solve this question. If you have like a rough work, you can solve it. Using the 3 sides, you have to calculate the area of the triangle. You have to use Heron's formula. or I think it is basically called the Brahmagupta formula, which is square root of s into s minus a into s minus b into s minus c. Once you get the area, you will have to figure out that the half the length of the altitude into the side xz will be the area of the triangle. So using that, you can calculate the length of the altitude. If you want, I can try to calculate it. What is the value of S? This is actually an isosceles triangle. So this is 20, 20, and 30. So this is 20, this is 15. So the 20 and 15, what is this length? I think that is square root of 175, right? That is 400 minus 225. Square root of 175 is the, okay, so the square root of 175 is 25 square root of 7. So the area will be 25 square root of 7 into 15. 25 into square root of 7 into 15 is equal to half into this is xz, right? Okay, half into 20. So this 25 into square root of 7 is equal to 10 into the height. So that will be 12.5 square root of 7. This will be the answer. So again, I got, I think, oh, that was wrong. Okay, I'm sorry, guys. But basically, you'll have to figure out based on that. But this is a very interesting way of solving it. And I would definitely want to give shout out to all the people who got it correct, all the people who have done well. So if you're looking at the Rush leaderboard, this is something, these are the guys who have done well. I don't know the first guy, his name, it was a nickname. The second is Apala Das, third is Vishal Datta, next is Pavani Pila. These are all Rush leaderboard. I don't know whether it is all time or in the last 1 month. And Aryaman, Dadwal, Hari Krishna, Maverick, VD Savarkar, Chaman, and Rahul Kumar Singh. So all of these guys have done very well. If you want to analyze the questions that you got wrong, like in my case, you can go to solutions. I especially want to see what went wrong in this particular question. I thought I got it correct. Yeah. So this is 2020. This is 5 square root of 7. Ah, okay. I think I put it as 15 square root of 7. Yeah, I put it as, so I got it as 12.5 square root of 7. It should actually be 7.5 square root of 7. Yeah, I think I made a mistake somewhere over here in calculating the area, which happens sometimes. But basically for this kind of a question, calculate the area and then you'll calculate the length of the altitude. Okay, guys, that is with respect to quant rush. Now let us start today's LRDI session. I particularly feel that if I was a student, I would really enjoy using the quant rush regularly. Okay, we have close to 100 guys who are watching the stream. Please do like the stream and please do subscribe to the channel. If you guys are into, after finishing 2 LRDI sets, I'll actually take another quant rush and I'll try to see if we can do better. Okay. This is the first question, guys. Try to solve it. The question is over here. I'll try to maybe reduce the font so that, okay. The question is on this side. The LRDI information that is given is over here. I hope you can actually see it. Or I'll try to slowly increase the font if needed. Yeah, I think this also should suffice. This is the questions, okay? It just starts off as there are 6 rice shops, A, B, C, D, E, F. Okay, nothing else is there. I think everything else is covered. Yeah, and that is the set. Try to solve the set and after that I'll show you the questions. Questions will be on this set. I know I'll be coming in the middle of the questions. Okay, which I don't want to do. Try to solve it using this. Yeah, people are asking what will this lecture cover. This lecture will cover 4 LRDI sets. I would say all the 4 LRDI sets are slightly easier than CAT, but they won't be very easy. I would actually say these LRDI sets will be definitely relevant for CAT. If you solve many of these kind of sets, you will definitely gain an advantage when you're trying to solve LRDI sets which are CAT level. For example, if I have to say that normally out of 10, if a LRDI set which is CAT level, an easy LRDI set is a 6 on 10, the difficulty. These will be 5 on 10. So it is not like this is a very easy set. These are slightly easier than CAT, but definitely relevant for CAT. And they'll be similar to what is asked in CAT. Whatever you're going to learn will definitely help you even in CAT. This is the first question. I'm going to put it up. First, second, and third questions are at least here. The fourth question I'll show you later. We have given around 12 minutes for this set. Try to see if you got it correct, then you can just post it in the chat. What are the answers for the first one, second one, and the third one? The fourth one I'll show you slightly later. This is the first question, this is the second question, and this is the third question. Somebody is asking how many questions will be done today. We'll be doing 4 sets today. This is the first set. There is 7 minutes left, so try to solve it in the 7 minutes. After that, I'll explain the questions. Samay is saying the first question's answer is 0. Samay, unfortunately, that is not correct. Please do try again. You can actually calculate which shop sold Arborea with certainty. Yes, Samay, the second one is correct. The second one is what you mentioned. Try to solve it, guys. We have still 6 minutes left. Nine C Dubai is asking a question. Hello, sir. Actually, I want to ask that for LRDI, should we start solving sets or first go through the concept videos? Because every time after covering the topics, there will be a new set that comes. That is a good question, Naini. What I would actually tell you is in LRDI, there is no fixed syllabus. In quant, you know that there is a fixed syllabus. Okay, you know these topics, and there are a bunch of formulae, like maybe say 150 or 200 formulae overall, and there are a set of topics. And you know that if I become very good at these topics, there is a very good chance I'll get the questions correct in the examination, unless because of pressure or stress or panic you underperform. But otherwise, you know that for certainty, a question is going to come from this syllabus. In LRDI, unfortunately, there is no fixed syllabus. So unless you solve more and more sets, you can never gain that confidence. So I would say you have to watch concept videos, but you have to also solve sets simultaneously. And you should not be demotivated or demoralized if a new set comes, because that is the nature of LRDI. In LRDI, you will always get some new sets which require a different way of thinking. But you should not be demotivated by it. Any set which is completely new will be completely new for all the aspirants. Secondly, if you're looking at CAT, out of the 5 LRDI sets that come, at least 3 sets will be standard. There will be a set in arrangements. There will be a set in DI, that is reading graphs, reading pie charts, reading bar charts. There will be a set like that. So at least some of the sets will be standard. So solving standard sets is always going to give you an advantage. And you should be mentally prepared that all the sets will not be something that you are familiar with. On the day of the examination, in mocks and all, also a new, completely new type of set can come. That is fine. But all the standard sets, at least you should gain more and more practice and more confidence. Okay, many people are answering this. I'm just going to give you some time. I'm going to go away from the screen, try to solve it. We have around 3.5 minutes left. After that, I'll give the solution for this set. Now I'm going to show the fourth question also. Try to solve it, guys. Yeah. This is 2, this is 3, and this is 4. Many people got many of the questions correct, guys. I think the first question, so many people got correct. I think Sarthak got many questions correct. Well done, Sarthak. Okay. After another 1 minute, I will start solving it. I won't wait for the time to run out. Okay, guys, last 1 minute. Try to solve it. This is the fourth question. This is the first question. Which shop sold Arborea is the first question. Then we have second, third, and fourth. Okay, these are the 4 questions. After another minute, I'll start solving the set. Aparna Nair posted all the questions. I think you are right in all the 4, Aparna. I will confirm after I start solving the set, because I don't remember the answer for the first one. Let us see. Okay. Last 10 seconds, guys. Try to solve it. After that, we'll start solving the set. Okay. The time is up, guys. So let me try to solve this set. This is the information that is given about 6 shops. The names of the shops are A, B, C, D, E, and F. And each one of them is picking a rice set out of Arborea, Japanica, Basmati, Della, Solana, and Bomba. There are 6 types of sets, 6 types of rice. And each one of them has a price in US dollars, which is a unique integer between 5 and 16. That is, it can be 5 or 6 or 7 or dot 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 till 15, 14, and 16. So for this kind of a question, where clearly there is a table kind of a thing, let us draw a table. The table will contain the shop name over here. Then it will contain the variety of the rice, that also will be over here. And it will contain the price of the rice. What are the names of the shops? The names of the shops are either A, then B, then C, or D, or E, or F. In this kind of a set, what I basically do is I go through all the instructions that are given. I'll try to fill the table as much as I can. Then I'll come back and I'll reiterate through all the clues, and I'll continue to keep filling as and when more and more information becomes apparent. Initially, when the table is empty, it becomes slightly like intimidating. But as you continue to reiterate through all the clues, you will figure out that filling the table up is not very difficult. Especially after a point of time, you should identify what are the clues which still have some juice left in it. For example, there will be some clues where direct information is given. If direct information is given, you put it in the table and then there is nothing else left in the clue. But sometimes there will be some inferences or some implications where you will figure out that, okay, this clue still holds some juice. I will come back to it the next time I'm reiterating. Once you're able to identify what are those type of clues, filling the table becomes easy. For example, in this particular case, what is the first clue? The first clue is that Arborea rice was the most expensive variety and it was not sold to shop B. So basically what is being told is that the variety Arborea is the most expensive. We don't know its price. And it is not sold to B. One thing you will immediately notice is this still holds some juice. I'm not filling up which of the shops has variety Arborea. If I know which one it is, then this clue will have no juice left. Right now, there is some information that is given, but I haven't used this information and filled the table up. So clearly, this has some juice left. 4 shops sold rice at an odd numbered price. So basically, what we are being told is that there are 4 odd numbers in the price table and there are 2 even numbers in the price table. Again, I haven't used this completely. So this also holds some juice in it. Shop E sold Basmati. Shop E sold Basmati would immediately tell that this is Basmati. Now this part holds no juice. If I'm reiterating through this clue and I read again that shop E sold Basmati, I'm going to get no extra information, no extra implication. So even in the examination, I would mentally switch off this part. Now the fact that this is not a prime number will hold some juice. So shop E Basmati is not a prime integer. So the price is either 6 or 8 or 9 or 10 or 12 or 14 or 15 or 16. It is not a prime number, so it is not 5, 7, 11, 13. Okay, this part again has some juice because I don't know what is the price of Basmati. Cost of rice sold by B was double the cost of rice sold by shop F. So if I'm assuming that cost of F is say X, cost of B is 2X. Immediately I should know that, okay, and I should think that, okay, I know that there are 4 numbers which are odd here and 2 numbers which are even. And this is one of the even numbers. Because it is 2 times X, so it is an even number. Now, shop D sold rice, which is the cheapest, and the price was an even number. So D over here is lowest and it is even. So one thing that I can figure out is I know what are the 2 even numbers. One even number is B, another even number is D. So everything else is odd. For example, Basmati has to be odd. It cannot be even. So it is not 6 or 8 or 10 or 12 or 14 or 16. This will basically be This will basically be only 9 or 15. These are the only two possibilities. Because 2 are even, 4 are odd. And the 2 even are D and B. So everything else has to be odd. For example, X is odd, this is odd, this is odd. And what are the values that X can take? Again, if you're thinking about it right now, X cannot be 5 because D is the lowest and D is even. So if X is 5, the lowest will be X itself. So X cannot be 5. X can be 6, it cannot be 6 because all the remaining 4 are odd. So X is either 7 or 8. Again, like I was telling you multiple times, this is odd, this is odd, this is odd, and this is odd. The only two even are B and D. So again, I would say that X cannot be 8. The only possibility is that X is 7. So if X is 7, this is 7 and this is 14. And now if I'm looking at what is D, D is the lowest and it is even. So D basically will be 6 because F is 7, D has to be less than 7 and D has to be even. So D is 6. Now I know P, I know D, I know F. I have to figure out A, C and E. These are all the things that you can keep getting better at as you practice more. Shop D sold rice, which was the cheapest, and the price is an even number. I think I went through this. Now I actually know the price of shop D. So this has no juice left in it. I have figured out that the price of the rice that was sold by shop D is 6. So when I'm reiterating, if I come to this particular point, I gain no information. So I can just ignore it. The cost of Bomba variety was more than that of the cost of Japanica, but less than the cost of Della variety. So basically, Della is greater than Bomba is greater than Japanica. The rice sold by shop B was costlier than the rice sold by shop A. So shop A sold less than 14. Because the price of the rice sold by shop B is 14, it is costlier than the price of the rice sold by shop A, so it is less than 14. When I fill the table up, this is what I'm able to fill up the first time I go around. Now I'll continue to reiterate through the clues. If I'm reiterating through the clues and the table is slightly filled up, I will be able to fill up more. So for example, if I'm going through it, Arborea rice was the most expensive variety and it was not sold by shop B. Okay. So now I try to figure out where was Arborea actually sold. Arborea is the most expensive and it is not in shop B. It is not in shop A because the price of shop A is less than 14. It is not D, it is not F because both of them are 6 and 7. It is either C or E, but Basmati is being sold by E. So Arborea cannot be sold in E. The only possibility is that it has to be sold in C. This is Arborea and it is most expensive. So it is more expensive than 14. So it is either 15 or 16. But can it be 16? Remember what we discussed. Only 2 are even and those 2 even are B and D. This has to be odd. So it has to be 15. Once you figure out that this is 15, this cannot be 15. This will suddenly become only 9. Let us look at, so now this clue has no juice left. We have figured out which one it is. 4 shops sold rice at an odd numbered price. This also has no juice left now because I, for example, know that this is odd, this is odd, this is odd, this is odd. I know which are the 4 shops which have sold odd numbered rice. I can actually try to figure out what it is for A. I know that it is an odd numbered rice. It is not 5 because the lowest is 6. It is not 7 or 9 or 15. The only 2 possibilities are that this is either 11 or 13. I'm yet to figure out whether it is 11 or 13, but we'll try to see. We'll go through the clues and try to figure it out. So this also has no juice left now. Shop E sold Basmati and was not a prime integer. That is fine. Basmati is 9. So now this has no juice left. I know that the price of shop E's rice is 9. The cost of rice sold by shop B was double the cost of rice sold by shop F. That is 14 and 7. Again, I have figured it out. So this clue also has no juice left. Just reading this clue multiple times is not going to give me any new information. The only 2 clues left are 6th and 7th. If I'm looking at 7th, the rice sold by shop B was costlier than the rice sold by shop A. That is fine, but I know that A has 11 or 13. I just don't know which one it is. So again, just by going through this clue is not going to give me any new information. I can strike this off. Cost of bomba is greater than Japanica but less than DILR. This is the only thing that is left. But again, using this, I can't figure it out. I know that there are 4 empty values in the rows. One of them will be this Solana, and the remaining 3 will be DILR, Bomba, and Japanica. These are the 4. Again, I know that DILR is the greatest, next is Bomba, next is Japanica amongst these 3. But I don't know where Solana fits in. Solana can be either the least, or it can be over here between Bomba and Japana, or it can be between DILR and Bomba, or it can be to the left where it is the highest, it is greater than DILR. Unless I know that, unless I have that information about Solana, I can't figure out this table. So this is the best that I can do with the information that is given. Let me go ahead and answer the questions that follow. Which shop sold Arborea variety of rice? The shop which sold Arborea variety of rice is C, which is 3. If Japanica variety is not sold at the cheapest cost. Okay, now this is new information. What is the cost of the Bomba rice? Because remember what we discussed. I know that amongst DILR, Bomba and Japanica, Japanica is the lowest. But what is being told to us is that overall Japanica is not the lowest. So that would imply that the lowest has to be Solana. This information is given that Japanica is greater than Solana. So this would imply that this has to be Solana, this is Japanica, this is Bomba, and this is DILR. So this is Bomba is what we can figure out, because new information is given that Japanica is not the lowest. If Japanica is not the lowest, the only possibility is that Solana is the lowest. Now we can figure out the order. Lowest is Solana, this will be Solana. Second lowest is Japanica, this is Japanica. Third lowest is Bomba, this is Bomba. And the next one is DILR, this is DILR. So now what is asked is, what is the cost of Bomba rice? Bomba rice is either 11 or 13. We know that it is 11 or 13, but we can't identify that it is either 11 or 13. So the correct answer is cannot be determined. What was the second highest price of rice sold by the shop? The highest is 15. The highest is Arborea. It is sold by shop C. It was for 15 USD. The second highest is 14. So the answer is 14. If the cost of DILR and Solana are consecutive integers, so what is the cost of Japanica rice in USD? Now what we are told is amongst these 4, what are the prices that are left for Solana, DILR, Bomba and Japanica? One of them is 11 or 13. The other one is 14. The other one is 6 and 7. Now we are told that DILR and Solana are consecutive integers. The only values which are consecutive over here are 13 and 14 or 6 and 7. But DILR is definitely greater than Bomba and Japanica. So DILR cannot be 6 or 7. 6 or 7 are the lowest. DILR is either the highest or it is second highest after Solana. DILR is not 6 or 7. So this case doesn't exist. So DILR and Solana are 13 and 14 in some order. What are the remaining 2? The remaining 2 are 6 and 7. So Bomba has to be 7 because Bomba is greater than Japanica and Japanica has to be 6 because Bomba is greater than Japanica. So in this question, if we are told, we are asked to calculate the price of Japanica, which will be equal to 6. This is how you solve the set. What I would recommend you to do and what I would request you to do is, please like the stream, because we are putting in a lot of effort into making these streams and we plan to do these streams every Saturday. We'll do these streams every Saturday from 2 to 4 p.m. in June and July, maybe August also. From September onwards, we'll be actually having longer streams in the afternoon, Saturday afternoon. Last year also we did it. We plan to do it this year also. Every Saturday from 2 to 4 p.m. we will be doing this kind of stream. So please do like the stream and please do subscribe to Cracku. The more people who subscribe, the more people who join next time when we do these kind of sessions, And if more people join, we will be more incentivized to conduct these kind of sessions, because it would mean that these sessions are actually helpful to students. So please do this, guys. It will mean a lot to us. Let us look at the next one. Okay, one other thing I wanted to tell you is with respect to Cracku daily targets. The Cracku CAT daily targets are very popular among students. This year, actually, we are getting record levels of daily targets which are being taken on a daily basis. I think last week, the number of daily targets that were taken in a particular day crossed 7,500. Like, that is a pretty insane number, that 7,500 daily targets were taken in a single day. Every day we are getting around 6,000 plus, and the highest till now for this year was 7,500, which is pretty big because it is still June, and as compared to last year, the number has increased substantially. Every year after CAT is over, when I interact with students, I always ask them, okay, what are the things that helped you? What are the things that you did right? What are the things that you did wrong? And I put up these videos on YouTube also, because I feel that when we talk to toppers, when we interact with them, some of the habits that people ignore will be very, very useful. Because many times when we interact with them, the toppers are not like different human beings. They are also similar to everyone. It is just that they do things on a consistent basis. And nearly every topper tells me that one of the things that they did religiously was the Cracku daily targets. I can't stress how useful they will be on the day of the examination. Every single day, please try to make time out of your day for around 30 to 40 minutes to take the Cracku daily targets. They will be very, very useful for you. Let us look at the next set, guys. This is the next set. I'm going to start the timer. There are, yeah. Basically, I'll go, yeah. There are 8 sections, A, B, C, D, E, F. This is the information that is given. Okay. Okay. I will move out, guys. Don't worry. This is question 5. Okay. These are the first 3 questions. After that, I'll show you the 4th question. Thank you. Please call our students in each section same. No, students in each section are not same. That is, information about all the 8 sections are different and independent. The number for section A is independent of the number in section H, and the number of students in each of the sections is also different. Okay. I think Shubhang is right. Well done, Shubhang, for the first question. Try to solve the remaining also. After some time, I will scroll up and show you the fourth question. Good job, work related, guys, and Samay. Both of you got the first question correct. Try to solve the others also. Okay, guys, I'll show you the fourth question now. This is the fourth question. This is the sixth, seventh, and eighth. That is, yeah. Try to solve it, guys. Yeah, I put it up Question 8 now, guys. Try to solve it. Okay, last 1.5 minute left, guys. Try to solve it. Bindu or Mesing, I'm not able to solve this because I've recently started preparing. Like I said, Bindu, these are not very easy sets. Definitely, I would say, I think this set is probably cat level. So these are maybe slightly on the easier side cat level, but not much easier. So these are sets which are not very trivial sets. These are not sets which are super easy. So if you are not able to do them, don't feel like super demotivated. Try to understand the explanations later. At least from the explanations, you will gain something. Okay, guys, last 1 minute. Try to solve it. Okay, guys, the time is up. Let us try to solve this set. So what is given in this section? In this set, we are told that there are 8 sections, A, B, C, D, E, F, G, and H. Every section has a certain number of students. Now, some of the students play cricket, some of the students play hockey, some of the students play both the sports, and some of the students play no sport. So if you're looking at any particular section, we will have a Venn diagram. This will represent the number of students who play cricket. And this will represent the number of students who play hockey. Now, if there is a student who is represented over here, this star, what does this represent? This represents a student who is part of this circle but not part of this circle. So this guy plays only cricket. What about this? I'll write another star. This star is part of only the circle which contains hockey. It is not part of the circle which contains cricket. So this guy plays only hockey. What about this star? This star is in the intersection. So this particular star represents the students who play both cricket as well as hockey. Now what about this star? This star is outside both the circles. This star is not part of the circle which contains cricket. This star is not part of the circle which contains hockey. So this represents the number of students who play neither of the two sports. This is basically something that you need to understand in Venn diagrams. The second thing you need to understand is, for each of the sections, we are given the percentage of people who play cricket, percentage of people who play hockey, but we are not given the percentage of overlap. That is, we are not given what is the percentage of people who play both the sports. If you are actually given that, solving this set becomes very easy. But because that is not given, we have some complications in the set. We are given the number of students who play neither of the sports. That is a useful information, but we also need information about the overlap, like this. Like for example, if you are told that, say, C people play cricket, H people play hockey, what is the total number of people who play both cricket and hockey, that is either one of cricket or hockey? You can't say that, you can't calculate that, because we need to know the intersection. For example, if you are told that the intersection is I, that is the total number of people who play cricket is C, the total number of people who play hockey is H, and the number of people who play both cricket and hockey is I, then you can calculate the total number of people who play either of the two sports. How can you do that? Because the number of people who play only cricket will be C minus I. Number of people who play only hockey will be H minus I. So now you can say that the total number of people who play one of the two sports will be C minus I plus H minus I, which will equal C minus I plus H minus I. This is equal to C plus H minus I. In the table, we are given the percentage of people who play cricket. That is, we have a sense of what this C is. We are given the percentage of people who play hockey. So again, we are given a percentage of the number of people who play hockey. But we are not given the intersection. That is, we are not given this I. When we are not given this I, we can't calculate exactly what is the number of people who play both the sports. This is something that I want you to understand before we start solving the set. Now, if you are looking at the set, with this information, let us try solving the set. If the number of students from section A who have taken up both the sports is 1/4 the number of students who play from section A who take up only cricket, what is the strength of section A? So in section A, let us assume that this circle represents the number of people who play cricket, and this circle represents the number of people who play hockey. Let us assume that the number of people who play both the sports is A, that is represented over here. Now we are told that the number of students from section A who have taken up both the sports is 1/4 the number of students from section A who take up only cricket. So if the number of people who play both the sports is A, what is the number of people who are playing only cricket? It is 4 times that. So this is 4A. So 4A people play only cricket. A people play both cricket and hockey. So the total number of people who play cricket is 5A. Now in section A, the percentage of people who play cricket is 25%. This would imply that total number of people who are part of section A will be 5A, which is the total number of students who play cricket, divided by 0.25, which is 20A. So the total number of people is 20A. What is the number of people who will play hockey? That is given, that is equal to 50%. If that is equal to 50%, the number of people who play hockey is 10A, which is 50% of 20A. Out of the 10A, A play both cricket and hockey. So the number of people who play only hockey is 9A. So what is the number of people who play either cricket or hockey? That will be 4A plus A plus 9A, which will come to equal 14A. The total number of students is 20A. Number of people who play one of the two sports is 14A. So what is the number of people who play neither of the two sports? That will be 6A, which is 20A minus 14A. This 6A is given to us. The value of 6A is 24. So once you are given the value of 6A equaling 24, the value of A is equal to 4. So the total number of students, which is equal to 20A, will be equal to 80. So the answer for this particular question is option C. Let us look at the next question. If none of the students take up both the sports, which section has the second highest strength? So now what we are basically told is the two circles which represent the students who are playing cricket and hockey, there is no intersection, because none of the students take up both the sports. So the circles are like this. This is cricket and this is hockey. Both of them are not overlapping. This is cricket and this is hockey. And we have the percentage of students who are playing cricket. We have the percentage of students who are playing hockey. If you add both of them, you are going to get the percentage of students who are playing either cricket or hockey. and you subtract that from 100%, you will get the students who are playing neither of the two sports. For example, if you are looking at section A, the number of students who are playing cricket is 25%. Number of students who are playing hockey is 50%. And both of them are not overlapping. There is no student who is playing cricket and hockey. So 50% are playing hockey, 25% are playing cricket. The sum of these two is 75%. What about the remaining 25%? Those 25% are playing neither of the two sports. That is equaling 24. Therefore, using that information, we can calculate the total number of people in section A. For example, in section A, it will be 24 divided by 0.25, which is equal to 96. What about the number of students in section B? Number of students who are playing cricket is 50. Number of students who are playing hockey is 10. Those two add up to 60%. So the number of people who are playing neither of the two sports will be the remaining 40%. That is 16 divided by 0.4 will give us the total number of students in section B. This will equal 40. Similarly for C, that will be 24 divided by, this is 20 and this is 30, totaling up to 50, and the remaining is 50, so this is equal to 48. Similarly for D, it is 30, and this is 24 and 36, they two add up to 60, the remaining is 40, so 30 divided by 0.4, which is equal to 75. Next we have E, this is 12, again divided by, I think this is 36 and 24 is 60, so again this is 0.4, this is 30. Next, if you are looking at F, F has 42 divided by, cricket is 20, hockey is 40, both of them combined is 60, the remaining is 0.4. 40 divided by 0.4 is 105. Next we have G, total number of students who are playing neither is 10, divided by 25 and 50 is 75, the remaining is 0.25, this is equal to 40, and finally we have H. H is 40 students are playing neither of the two sports, and cricket is 40, hockey is 10, that is 50, divided by 0.5, this is equal to 80. Which of them is the highest? F is the highest. Which of them is the second highest? A is the second highest. What are we asked? We are asked which of the section has the second highest strength. Second highest strength has to be option A, which is section A. Now, what is the difference between the minimum strength of G and the maximum strength of section F? So, we'll first calculate the minimum possible strength of G. If you are looking at the minimum possible strength of G, what do we know about G? What we know is number of students who are playing neither of the two sports is 10. Cricket is 25%, hockey is 50%. So if you are having an overlap like this is cricket and this is hockey. Now cricket has 25%, hockey has 50%. If you don't understand it intuitively, I will tell you mechanically how to do it. Assume that the number of people who are there in the class is X. Total number of people who are there in the class is X. How many of them are there in cricket? That will be X by 4. How many of them are there in hockey? It is X by 2. We don't know the overlap. Now, if both of them combined, okay, if we can get it to be as minimum as possible, the people who are outside the circles will be as maximum as possible in terms of X. Then we can try to minimize the value of X. For example, if you assume that the number of people who are in the intersection is, say, A. The number of people who are playing only cricket is X by 4 minus A. The number of people who are playing hockey is X by 2 minus A. So the number of people who are playing either hockey or cricket, like we discussed earlier, will be this plus this plus this, which is equal to 3x by 4 minus A. This is the number of people who are playing either cricket or hockey. So what is the number of people who are playing neither cricket nor hockey? That is all the people who are in X but not part of these two circles. that will be x minus 3x by 4 minus a, which will simply equal x by 4 plus a. This is the number of people who are part of neither of the two circles. This information we know. With respect to G, we know this information. That we are told is equal to 10. Or the value of x is equal to x plus 4a is equal to 40, or the value of x is 40 minus 4a. So if you're trying to maximize the value of x, if you're saying that I want to maximize the value of x, then you will make a to be equal to 0. Then the maximum value of x is 40. If you're trying to minimize the value of x, that is, if you want to minimize the total number of people who are part of section A, you should try to maximize a. But what is the maximum value of a? That is, what is the maximum value of this overlap? The maximum value of the overlap is equal to x by 4. If I'm told that the number of people who are playing cricket is x by 4, the number of people who are playing both the sports cannot be x. For example, intuitively, if I'm telling you that there are 10 people who are playing cricket, 20 people who are playing hockey, the number of people who are playing both the sports has to be less than or equal to 10. You can't have 10 people playing cricket, 20 people playing hockey, and 15 people playing both the sports, because 15 cannot be more than 10. So the maximum value of a will be equal to x by 4. So if you're trying to minimize the value of x, you make the overlap be equal to x by 4, because that is the maximum value that a can take. Now if you're substituting it over here, you are going to get 4a will be equal to 2x, or the value of x will be equal to 20. So the minimum possible value of the number of students in G is equal to 20. So this is minimum 20. What is the second thing that we are asked? We are asked to calculate the maximum strength of section F. We'll do the same thing again. So if you didn't understand this properly, you will understand it this time. Because now you are asked to calculate for F, I am trying to maximize it. If I'm trying to maximize it, what will I draw for F? F, again, I'm going to draw two circles. This is cricket, this is hockey, this is cricket, this is hockey. Let us assume that the total number of people who are part of section F is, say, F. What is the number of people who are part of cricket? That will be 20% of F, which is 0.2F. The number of people who are part of hockey is 40%, so this is 0.4F. Again, I don't know the overlap. I don't know how many of them play both cricket and hockey. Let us assume that B people play both cricket and hockey. So how many people play only cricket? It will be 0.2F minus B. How many people play only hockey? It is 0.4F minus B. So how many of them play either cricket or hockey? That will be this plus this plus this, which will come to equal 0.6F minus B. So what is the number of people who play neither cricket nor hockey? From F you subtract this, that will be equal to 0.4F plus B. Now what we are told is 0.4F plus B is the number of students who play neither of the two sports. That is equal to 42. Or if I'm just multiplying this entire equation with 2.5, F plus 2.5B is equal to 105. Or the value of F is 105 minus 2.5B. Now I'm trying to maximize the value of F. I'm not trying to minimize the value of F. If I'm trying to minimize the value of F, I'll try to maximize 2.5B. And I know that the maximum value B can take, I will go back to the circle. Which of the two is lesser? It is 0.2F. So if I'm trying to minimize the value of F, I will maximize the overlap. I will say that B has to equal 0.2F. But here, I'm not trying to minimize the value of F. I'm trying to maximize it. So if I'm trying to maximize F, this one, I have to minimize B because it is 105 minus B. But if I'm trying to minimize the value of B, the minimum value B can take is equal to 0. Therefore, the maximum value of f is equal to 105. So what we are essentially saying is this is equal to 105. So maximum value of f is 105, minimum value of g is 20. The difference between both of them is 85. So the answer for this particular question is option C. What about the last question? In section D, if at least one student takes up both the sports, which of the following is the strength of the class? Now, in section D, I have no sport is 30, cricket is 24%, hockey is 36%. So let us assume that this is cricket, this is hockey. Let us assume that the total number of people who are part of section D is say D. What is the percentage of people who are playing cricket? That is 24%. So this will be 24 by 100 into D. Simplified, it will be 6D by 25. What is the number of people who are playing hockey? Hockey is 36%. So this is 36 by 100 into D, which is 9 by 25 into D. What is the number of people who are playing both the sports? Do we have any information about it? We have some information. We are told that there is at least one guy who is playing both the sports. So let us assume that the number of people who are playing both the sports is B, and B is greater than or equal to 1. This is the information that I have. So what is the number of people who are playing only cricket? It is 6D by 25 minus B. What is the number of people who are playing only hockey? It is 9D by 25 minus B. So the number of people who are playing either one of the two sports will be this plus this plus this. If you are simplifying it, it will be 15D by 25 minus B. Therefore, the number of people who are playing neither of the two sports will be D minus this. What is D minus that? It will be 10D by 25 plus B. This is the number of people who are playing neither of the two sports. And that information is known to us. That is equal to 30. Or 2D by 5 plus B is equal to 30. Multiply this entire equation with 5, you are going to get 2D plus 5B is equal to 150. We are required to calculate the value of D. We have only one equation. Using this one equation, how can we calculate the value of D and B? Now, even though we have one equation, we have information that the number of people who are playing, who are part of section D is an integer. The number of people who are playing cricket from section D is an integer. The number of people who are playing hockey from section D is an integer. So we know, for example, that 6D by 25, this is an integer. 9D by 25 is an integer. This would imply that D has to be a multiple of 25. If D is not a multiple of 25, the number of people who are playing cricket or hockey from D will not be an integer. You can't have 15.5 people playing cricket. You will have either 15 people playing cricket or 16 people. You won't have fractions. Once you know that D is a multiple of 25, you can then calculate the values of D and B. For example, 2D plus 5B is equal to 150. And we know that B is greater than or equal to 1. So 2D has to be strictly less than 150, or D has to be less than 75, and D has to be a multiple of 25. The only two values D can take are 25 or 50. Now, what is the number of people in D who are playing neither of the two sports? We have 30 people who are playing neither of the two sports. So the number of people in D cannot be 25. D has to be greater than or equal to 30. The only possible value is 50. So the number of people in section D has to be 50, which is option B. If you have any doubts in these two sets, please do comment after the session is over. I will look at the comments and I'll try to explain it to you. Let me look at the next one. Yeah, one thing I wanted to tell you is we have a new batch that is starting on Monday. This is a around 5.5-6 months batch. It will be very useful for you. I think this is the time when you need to put in a lot of effort. This is when your momentum for your CAT preparation has to start really picking up steam. If you are looking to enroll to it, you have to just Google search Cracku CAT 2026 course. If you Google search Cracku CAT 2026 course, you will get our page and you'll get all the details that are there. Otherwise, you can just call us on this particular number 6303239042 to get any of the information. We have weekly live sessions. We have daily classes from Monday to Friday in the evening. We have 2 hour classes every day. I take the classes on Monday. Sayali takes the classes on Thursday. And we have one-to-one mentorship and we have a daily schedule. It is a very good course. I hope you can actually check it out. Again, if you have any doubts, you have to just Google search Cracku CAT 2026 course or call us on this number. Now, I'll give it off to Sayali. Do you want to do a quant rush?
Okay. Okay. I'm going to do it now. Okay. Just go to practice and then go, no? Study material. Okay.
Yeah, okay. Are you ready?
Okay. Okay, let's do.
Which topics?
Arithmetic or anything, actually. Hey, why? Okay, okay, it's okay, start. Let's do it. What is the remainder when this is divided by 35, 35, 230.
0.
Yeah. Ram wrote a book and published it. He later noticed that out of the 480 pages, 1 page was missing if the sum of the numbers on all the pages is equal to.
Oh, the numbers and all. Is it sum of digits or something?
Sum of numbers on all the pages is equal to this. What is the sum of all the digits of the page number that is missing? Okay. So you have 480 pages. If you had all 480, it would be 480 into 481 by 2 minus 11 5080. So this is 240. No, we don't have calculator. It's okay. 481 into 26, 192. This is 360, so 9. Okay. What is the remainder? Then this is divided by 13. 9, 6, 36. 2 and 6 is. But it is prime, no? So we can remove like 26. We can remove till 8 at least. It will become 6 to the power 8 by 13 because 39. No, not 8. 39, 11. 6 to the power 11 by 13. Okay. No, not 8 only. 40. So 45 raised to 2 by this, right? Because raised to 30. Okay, sorry, raised to 12 will be this. So 48 is gone, 45 square by 13. This is 6 into 6, 36 by 13, so 10. How do I put this?
Are you sure?
Okay.
Close that. I think we got it wrong.
Really? No, so much faith you have in me, okay, Maruti?
Okay, this is the last
one.
question.
Okay. A is this, B is this. If 200 times A plus 100 times B, what is the value of the largest integer less than or equal to S? So I'm going to clear this one. Okay. 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 So 9.099. This is basically divided by 11. What
Yeah.
happened? Oh, okay.
Okay.
Okay. 200 times A plus 100 times B. This is basically what? 9.09 by.
I think it is.
This is into 11 would be how much? This is 99.99.
Into 10 kar do.
So 100 by 11 is 9.09, whatever.
Okay, it is 1 by 11.
So 1 by 11. Yeah, 1 by 11.
And 9 by 11.
9 by 1 by 11. And B is 81.
It is just into 9, right?
Into 9.
So
So 9 by 11. So we have 200 plus 90. 900 by, okay.
100.
1100, okay.
I gotta
So
get
it
it
is,
correct.
Okay.
Okay,
Okay.
cool.
Chalo.
Guys,
Okay.
I feel that this is a very fun thing, so I would recommend you to try out the quant rush.
Okay, fine. Okay, so guys, let's go back to our this LRDI session. I hope you guys start using the quant rush regularly because it's a fun thing to do. I also enjoy it sometimes when I'm free. I don't have a lot of time. I try to do the quant rush just for like general practice. So let's go back to the session. Okay. So if you guys have, I think Maruti has already talked about the daily targets. So, and this is his session. Okay. So if you guys are looking for a structured way to prepare for CAT, please do check out the batch which is starting on Monday. So just search for Cracku CAT 2026 course. We have batch starting Monday. If you have any questions about the batch, about like what is going to be covered in it, just reach out to us on this number. That is 630-323-9042. We'll be happy to answer any of your questions about the Apex batch. But I'll just tell you what is included in the batch. We have daily live classes. We have classes from 7:30 p.m. to 9:30 p.m. All the syllabus will be covered during this time. We'll also have like a lot of practice in that. We will make sure that you learn everything from basics to advanced. We have weekly revision. We have day-wise schedule. So every day you also get a pre-recorded video to see. So base is built there. It is then revised during the live session so that we have end-to-end coverage. From basic concepts to like very advanced concepts, everything will be covered with practice. We also have one-on-one mentorship so that if you have any questions about like how do you prepare, how should you refine your mock taking strategy, we have expert mentors who can guide you about that. So do check out our Apex batch. It starts Monday. Okay. So let's start with the this. Okay. So before giving this, I just want to give you a before giving the next LRDI. The LRDI is on knockout tournament. So I'll give you just some brief about what is a knockout tournament and exactly how should you represent information. See, in LRDI, there is no everything has to be done through representation format. If you know the representation format, it becomes possible to solve. If you don't know the representation format, you don't even know how to get started. So for knockout tournaments, what is the representation format? I'll explain. But firstly, what is a knockout tournament? So if you guys know, like say consider IPL, okay? IPL is a multi-stage tournament. The first stage is like a round robin where people play within, all the teams play within each other. It is, you get points for it. And once the final 4 are selected, once the last 4 are selected, then it becomes a knockout tournament. In a knockout tournament, if you lose a match, you get knocked out. So hence the name knockout tournament. Now it can be for the final 4, it can be for the top 8, it can be for top 16, anything like that. But a knockout tournament basically means that you lose the match, you get knocked out of the tournament. If there are like say 4 teams, how would a knockout tournament work in that case? So you would have 2 teams play each other, say A and B and C and D. These 2 teams play each other, these 2 teams play each other. Suppose A wins and suppose C wins, okay? In this particular scenario, D gets knocked out. So D is removed from the tournament, B gets removed from the tournament. And A and C play against each other. And suppose A wins. Then again C gets knocked out from the tournament. So essentially in a knockout tournament, you have to basically have 1 loser per match as such. So if there are 4 teams, how many games do you need? Because one person gets eliminated per match, you need 3 people to be eliminated, B, C, D to be eliminated. So for a knockout tournament, for you to get a winner, you have to basically, if there are n teams, there have to be n minus 1 losers. For n minus 1 losers, you need n minus 1 matches. So if there are 4 teams, you need 3 matches. 1 over here, 1 over here, 1 over here, total of 3 matches. 3 matches will yield 3 losers, and those 3 losers will get knocked out, so that you get one final winner. If you have 8 teams, how will that look? If you have 8 teams, you will have, say, A and B play against each other, C and D play against each other, E and F play against each other, G and H play against each other. These will be the 8 teams, okay? From these, say, first group plays against each other. Suppose A wins and C wins. So again, A and C will play against each other. Say A wins that. E wins and say G wins. E and G will play against each other, and suppose E wins that. So you will have finally A and E playing against each other, and they suppose that A wins. Again, you can represent, if you have any kind of n number of people, you will have a representation format like this, where you will have like a tree-like structure. So you need how many matches? Since there are 8 people, there have to be 7 losers. 7 losers means there have to be 7 matches. 1 over here, 2 over here, so that is 3, plus 4 over here, so that is a total of 7. So always remember, if there are n teams, you need n minus 1 losers. If you need n minus 1 losers, you will need n minus 1 knockout matches. Okay. The second thing, suppose you do not have, here all of the cases that I've considered is when you had a power of 2 number of teams. So suppose you don't have a power of 2 number of teams. Suppose you have, like, say, instead of having 16 teams, suppose you have 15 teams. What should that one team do? So there'll be like one case where there is, when like a team is not there, like there's an odd number of teams. So what you do in that kind of scenario is that you give a bye to one of the teams. So here 15 is very close to 16, right? So then you say that let it be the same structure as a 16 match. So say this is 1 team, 2 team, 3 team, 4 team, 5 team, 6 team, 7 team, 8 team, 9 team, 10 team, 11, 12, 13, 14, 15, 16, okay? But here, instead of having 16 teams, you have only 15 teams, which means that the 15th team, instead of playing the 16 against the 16 team, the 16 team will essentially be a dummy match. So the 15th team will get a bye. Here, I can give a bye to the lowest ranked team or the highest ranked team. The number of byes essentially have to be the number of dummy matches or dummy teams that have to be there before I have an even number of teams. So suppose if I have 15 teams, I need one dummy match so that I can get to 16, and this is a power of 2. So this will be 2 raised to 4. If I have, say, 28 teams, a power of 2 close to it is 32. So I'll say that I'll convert this to a table of 32. So I'll need 4 dummy matches before I get an even number, even pairing of teams as such. So this is basically when you have an odd number of teams, or you basically don't have an multiple of 2 kind of teams. Now, I'm going to give you a knockout tournament. If anybody has a question till now, just ask me. Otherwise, I'll give you an example about knockout tournaments, and I'll tell you exactly the format that you have to follow for that. Anybody has any question till now? Just ask away. If you didn't understand anything till now, just ask, and then I will tell you exactly what you have to do. We'll have one knockout tournament question, which is about 64 teams. And I'll tell you how to represent information for that particular tournament. But does anybody have any question for this till now, what we have discussed? It has to be a multiple or a power of 2. You want it to be a power of 2. Suppose if I have 16, then it becomes very easy for me. I have to basically make powers like multiples of 2 each time. If it is a power of 2, it becomes very easy. If it is not a power of 2, what I do is I consider dummy matches so that I make it a power of 2. So suppose if I have, say, 60 teams, what is the power of 2 which is close to 60? It has to be greater than 60. The power of 2 which is close to 60 is 64. So then I will say that consider 4 dummy teams. If I consider 4 dummy teams, then I will get to 64, right? What are these dummy teams? They are essentially buys. You give buys to the top 4 players. They directly go to the next round. The remaining 60, the other 60 players, like 56 players, have to actually play their matches and they play against each other. So then top four will essentially directly go to the next round. The remaining 56 will have to play the next round. So then you will have 4 plus 28. 4 plus 28 is 32. You get a power of 2 and then you can continue as normal when it comes to knockout tournaments. Okay. What is an upset? I'll explain that to you. Ma'am, is there a way we can know what topic questions will be in marathon so that we can revise it and come? That's we'll try to announce it beforehand, but generally we give the broader topic. But I agree with you, we'll give more refined lists. So if I'm doing a LRDI marathon, I'll tell you which topics are there so that you can see beforehand. I'll try to do it from the next time. What is an upset? I'll explain that. It is there in the next option. So I'll first explain the representation format, then I'll come to upset. So suppose if you have 64 teams and they are playing a knockout tournament, how do you show these 64 teams playing a knockout tournament? What you have to know is that in the first round, this is say the first round, okay? In the first round, the first team will play, first seeded team is the highest seed. First seed means basically the top ranked team. Second seed is the second ranked team and so on. So the first team plays with the lowest ranked team. Here, since there are 64 teams, the lowest ranked team is 64 team. The second team will play the second lowest ranked team. Because this is 64, this will be 63. 3 will play 62, 4 will play 61 and so on. Finally, 32 will play 33. Can you notice something over here? The sum of the team numbers has to always be equal to 65. So in the first round, the sum of the team numbers is 65. So if I want to find out quickly, who does team 27 play against? So 27 will be here somewhere. Who would it play against? I'll say 65 minus 27. This is 38. So 27 will play against 38. Sum is equal to 65. It is fitting the pattern. So you have to essentially say that this is the first round pairings. What would be the second round pairings? Second round pairings is if the top seeds always win. If the higher ranked players always win, then 1 to 32 should go ahead. If the higher ranked player loses, so suppose 1 loses to 64. If the higher ranked player loses to a lower ranked player, it is called as an upset. Upset basically means that you don't expect something to happen. You always expect the top ranker to beat the bottom ranker. When it doesn't happen, you call it as an upset because it upsets your expectations. Okay? But suppose there is no upset. If there is no upset, what do you expect to happen? 1 will win against 64, 2 will win against 63, 3 will win against 62 and so on. 32 will win against 33. So in the second round, without an upset, you expect 1 to play against 32 because 1 to 32 have gone to the next round. And then 32 will be the lowest ranked player and he will be the winner of the 32nd match. So 1 will play against 32, 2 will play against 31, 3 will play against 30 and so on. Finally, you will have 16 playing against 17. What is the sum of the team numbers over here? 1 plus 32, 33, 2 plus 31, 33, 3 plus 30, 33. So the sum of the team numbers will be 33. So if I ask you, who does the team number 20 play against? 20 will be on this side and 20 will be 33 minus 20. They will play against team number 30. Okay. Third round. Third round you will have, suppose there is no upset. Who will play against who? In third round without an upset, you will have 1 to 16 go ahead. Now the winner of the first match will play the winner of the 16th match. So you will have 1 play against 16, 2 play against 15, 3 play against 14 and so on. Finally, you will have 8 play against 9. What is the sum of team numbers over here? 1 plus 16, 8 plus 9, it is 17. Fourth round, okay, now going to the fourth round. If there is no upset, what do you think will happen? 1 to 8 will go forward. 1 will play against 8, 2 will play against 7, 3 will play against 6, 4 will play against 5. The sum of the team numbers will be 9. If again you have no upset, 1, 2, 3, 4 will go ahead. 1 will play against 4, 2 will play against 3. You will have, this will be 2 matches. This will be called as the semi-final. This will be called fourth round or the quarter final. And then if again there is no upset, the final will have 1 versus 2 and 1 is expected to win if there is no upset. This is the table that I want you to draw. The first table that you draw is that what happens when there is no upset. First round, second round, third round, fourth round, fifth round. last, final, semi-final, what happens? Now, why do you draw this table without upsets? The reason for that is that whenever you want to figure out who is going to play against whom, you assume that the person who has done an upset takes the place of the person he has upsetted. So if I say that, suppose like the player number 40, team number 40 reaches and wins the final, who does he play along the way? So 40, if I want to find out who does 40 play against, I will say that who does 40 play against in the first match? 40, 65 minus 40, he has to play against 25. 25 and 40 play against each other. Now he has to basically take the place of 25. It's like he kills 25 and he takes up his identity. So in the next table, you have to see where is 25 playing, and instead of 25, you're going to swap him out and put 40 in. So here, where will 25 play? 25, 33 minus 25 is 8. So he is going to play against the person who is 8. But instead of 25, we have 40 over here. Third match. Again, now, because 40 has again done an upset, he has to now basically kill 8 and take the place of 8. So in the next round, you're not looking for 25. You're looking for where 8 will play. Where would 8 play in the third round? The sum of the numbers has to be 17. So 8 is going to play against 9. So instead of 8, you will have 40 play against 9. Next round. Again, over here, 8 is still in the play. 8 is playing against 9. He's actually the higher rated. So 8 will continue to be in play. So instead of 8, you have 40 over here. Now you have 1 against 40, 1 upsets again, and 1 wins against 40. So where will he come in the final and the semi-final? He'll come in the place of 1. So this will be the 40th player. This will be the 40th player. So who is exactly 40 going to play against? He is going to play against 2 in the final. He is going to play against 4 in the semi-final. He is going to play against 1 in the quarter-final. In the third round, he is going to play against, where would the 18th guy be? 8th guy be over here. 8th, he is going to play against 9 in the third round. He is going to play against 8th in the second round. And he is going to play against 25 in the first round. That's basically what you do. Every time he plays against a higher rated player, if he is creating an upset, you say that he is going to kill that person and take his place in the further rounds. But first make the table without an upset. And then whenever an upset takes place, you basically assume that take the higher rated player out, put this lower rated player in. That same table, that same combination will continue. Just one higher rated player will be removed and the lower rated player will take his place. This is the format to be followed for any knockout tournament. So if you have a knockout tournament, make the table without upsets, and whenever the question asks, okay, whom does he play against with an upset, you have to do this. Okay, everybody understood this? Any questions till now? How are dummy teams plays in a tournament? So they will basically give you in the question instructions, they will tell you, generally the dummy teams are placed at the top. So the first 4 teams get a bye. If you consider like say Wimbledon, so the people getting the bye are the top seeds, not the bottom seeds. In chess, sometimes the bottom seeds get a bye, not the top seeds. So it depends on the format and it will be given in the instructions who gets the dummy team or who gets the bye. A bye and a dummy team is the same thing. You basically don't play a match. Okay. Okay. Anybody has any questions about this? No questions? We can move forward. So I'm going to give you a knockout tournament set with 64 teams. I want you to make this table first without an upset, who is going to play whom. And then whenever a question is asked about an upset, who plays, do the same thing. Again, now if I say that, okay, everywhere I have removed 40 and I have put a person who is playing in place of 40. But same way, 40 the way I have essentially had 40 being replaced, I can have somebody else also come in its place. So for example, over here, okay, 40 is playing against 8. But 8 could also have suffered an upset. If 8 suffered an upset, who could have come in his place? 8 plays who over here? 8 plays 65 minus 8. He would have played 57. So we could have had 8 and 57. So instead of 8 in the second round, 40 could also have played 57. So this is the second order of thinking that you have to do. Firstly, whenever I upset, I put him in the place of the person he has upset. And secondly, the person he is going to play against, even that person could have suffered an upset. So I get alternative possibilities for that person also. So that is the second order list that you have to think that, okay, who can 40 possibly play against in the second round? He can play against either 8, or if 8 was upset in the first round, he will play against 57. Okay, suppose 8 was not upset in the first round. Consider he is playing against somebody in the third round. Who does this guy play against in the third round? He 40 plays against 9. Who could be taking the place of 9? 9 in the second round is supposed to play against 24. So he could be taking, he could, instead of playing 9, he could be playing against 24. Or 9 could have actually been upset in the first round itself, and he could be actually playing 65 minus 9 would be 56. He could be playing 56 also instead. 56 could have been taking the place of 9. So instead of 24, he could have 56 also over here. There are multiple possibilities of who he could be paired against, given the fact that I can upset and so can the opponent be upset. So you have to consider all of those possibilities when making a list. Okay, I hope this is understood. We will go through that list making process in the actual question. But the first thing that you need to know is the format. This format you have to write sum is 65. This format you have to write sum is 33. This format you have to write sum is 17. This format you have to write sum is 9. Each time an upset occurs, remove that person, put that person who has created that upset in the original place of the person he has defeated. Okay, that is the very basic thing that you have to do when it comes to knockout tournaments. So let us get started with this particular set. I'm going to give you 12 minutes for this. I hope all of you guys attempt it. It's not a difficult set. It is a pure knockout tournaments, very, very basic set. This is the kind of set which is like you should definitely try. If a knockout tournament comes, this is like the base concept of a knockout tournament. Okay. Between 57 and 40, who will win the match if it was an upset? Will it be 57? Yes. An upset is the lower rank guy winning. So between 40 and 57, who is lower rank? 57. So if it is an upset, 57 is winning. If it is not an upset, 40 is winning. Okay? Okay. So all of you, this is the instructions. The instruction is nothing other than the basic description of a knockout tournament. Read these instructions and these are the questions you have to solve. This is question number 9. This is question number 10. Question 11. And question 12. You can pause and see the question again. Okay, you can pause and see the instructions again. So this is the full instructions, full set of questions. Come on guys, I want every one of you to attempt. Okay. Question one again. You can basically pause and see it. Okay, guys? Just pause the video and see the questions. Ma'am, if I start preparing for CAT now, can I get a good percentile? Absolutely. But you need to make sure that you don't waste any time. See, June, once June comes, you have like limited time. It's enough time, but it is limited time. You can't afford to waste even a day or so. So you have to be sure that you have a proper plan to crack CAT. So if you guys are preparing or starting right now, make sure that you have a proper plan in place. If you have a structured way to prepare for CAT, you will definitely crack CAT in this by November. But you need to make sure that you have proper guidance, proper content in place, and that you work consistently 2 to 3 hours every single day. If you want to take a look at a structured way to prepare for CAT, do check out our Apex batch. It starts on Monday. So a lot of people like you will be joining you and preparing for CAT from Monday. Okay. This is the second question. Aparna, to answer your question, with the 8,000 rupee discount, if you join now, it is at 22,000 rupees. But if you have other academic qualifications, if you have like very good score in 10th, 12th, or if you've taken CAT before and if you've done well in CAT before, you can have further scholarship. So what I would suggest is that either reach out to us or check the scholarship box which is there in the courses. You can get further discount also. But at the moment, we have an 8,000 rupee discount that is going on for the course. So do check out. The link is there in the chat box. So you can see from the chat box what the total course price would be for you. Okay. Some people have answered question 10 also. This is question 11. Neelam, yes, almost every Saturday we take a class. So we generally take a 2 hour or 3 hour marathon. Once like CAT season properly starts around August, September, we start taking like 3-4 hour longer marathons. In November, we take like even longer, like 4-5 hours marathons. But on Saturday, every Saturday, we try to do one stream on YouTube. So if you guys are interested in these pre-streams, I would say that please subscribe to our channel so that you know the updates about when we are going to do a longer stream. Okay. Guys, do the 11th question also, come on. Some of you have answered 9 and 10. Try to answer the 11th question also. Okay, thank you. Thank you. Coffee. Guys, there's a small request from my side. Those who feel that the stream is useful for you, please like the stream. It helps us reach more students. It motivates us to do more of these streams. So if you feel that this stream is useful, you want to see more of us in the future, so please like the stream and subscribe to the channel. Okay. Okay, some have answered 11 also. Last one, 12th question. 3 minutes remaining. Come on, guys. Solve the 12th question also. Shruti, try again. You're close to the answer. Try again. Okay, last 30 seconds, guys. Come on, try to solve all the questions. Okay, so time is up, and I see most of you have been able to answer the first question correctly. So you have at least like some idea of what is going on in knockout tournaments. So let us follow our format. Many of you got the answers correct, but for those who didn't, it's fine. This is the first time you are even looking at the format. You use this format consistently. There's no reason why you can't do knockout tournament questions. So let's start how to do this knockout tournament. So there are 64 tennis players, each of whom have unique seeding from 1 to 64 player tournament. Seed 1 is highest seed, 64 is the lowest. So as expected, this is the normal seeding. 6 rounds, first round, second round, third round, quarterfinals, semi-finals and finals. As expected, fourth round was quarterfinals, right? Semi-finals, finals are played to decide the winner of the tournament. In the first round, the highest seeded player plays against the lowest seeded player. So one plays against 64 and this is the first match of round 1. 2 plays against 63. This is the second match of the first round. Similarly, 32 plays against 33. This is the 32nd match of the first round. In the first match of the second round, the winner of the first match of the first round plays against the winner of the 32nd match of the first round. So one will play against the winner between the match of 32 and 33. Similarly, the winner of the second match of the first round plays against the winner of the 31st match of the round and so on. So this is the typical knockout pattern. There is no change, no alteration. So we'll make our knockout table. So what was the case for the first round? The sum has to be how much? The sum has to be 65. So 1 plays against 64, 2 plays against 63, 3 plays against 62, 4 plays against 61 and so on. Finally, for the 32nd match, 32 plays against 33. The sum of the team number should be how much? It should be 65. This is for the first round, okay? Consider second round. Second round, you have, if there is no upset, then you will have 1 playing against 32, 2 playing against 31, 3 playing against 30, to finally you will have over here 16 playing against 17. The sum of the team numbers 1 plus 32, this is 33. Third round, what do you get in third round? You have 1 to 16 playing. So 1 will play against 16, 2 will play against 15, 3 will play against 14 and so on. Finally 8 plays against 9. The sum of the team numbers is 17. Then you have the quarterfinal. Here in quarterfinal, 1 plays against 8, 2 plays against 7, 3 plays against 6, 4 plays against 5. You have the semi-final. You have in semi-final 1 playing against 4, 2 playing against 3 and then finally you have the final, you have 1 playing against 2. Here the sum of the team numbers is 9, sum of the team numbers is 5, sum of the team numbers is 3. This is the expectation if there is no upset. With this board, with this table in front of us, now I can go to the questions and see what the questions are. The first question that is asked of me is that if a player of lower seed defeats a player of a higher seed in the match, then such a match is called as an upset. If each of the 64 players had become part of only one upset match, then who is the lowest seeded player who could have won the tournament? Suppose, okay, one wins against everybody, only the one match that it gets upset. Okay, there is only one upset per player. So therefore, there are going to be 64 upsets as such. So if the one upset that one faces is in the final, so he's in the final, so he can play against the person that who has come to the final against him. So it can be 2 or the person who has either upset 2. So say 2 suffers an upset in the semi-final. Then it will be 1 against 4. Here 1 will face an upset and then 4 will win. That would be the lowest ranked player in that case. If the upset is occurring in the final, then we get that, okay, 4 is the lowest ranked player who can possibly win. But I don't want that to be the case because there is some way in which instead of getting the upset in the final or the semi-final, if I have upsets like earlier, I can actually have more lower ranked players. If I don't have the upset in the first round, If there is no upset in the first round, who are the players going ahead? 1 to 32 is going ahead. If there is no upset in the second round, who is the players going ahead? 1 to 16 are going ahead. So if I have any upsets after this, for 1 to 16, if the upsets only come after this, basically only 1 to 16 will win. So the lowest ranked player will be at most 16. So the earlier I have my upset, the lower the rank the player will go through. So if I have upsets in third round, quarterfinal, semi-final, final, I will not actually minimize the seed of the player. I will not have the lowest ranked player if the upset is later on in the tournament. If I want to have the lowest ranked player reach the final, I should have my upsets earlier on in the tournament, which means that the earlier on it is, the better it is. So if the upset is in the very first round itself, all the upsets come in the first round. 1 gets upset, 2 gets upset, 3 gets upset, all of them in the first round. 32 also loses his match. Then who actually goes forward? 33 to 64 go forward, which means that the one upset is over. Okay, one upset per player is over. 33 to 64 are going on from the second round onwards. Here there is no more upset because 33 has already had one upset. He has upset 32. 32 has lost because of an upset. 64 has had one upset. He has upset 1. So from this point on, second round onwards, there is no upset after that. So instead of having 1 to 32, you have 33 to 64. 33 will take the place of 32, 64 will take the place of 1. But essentially, instead of this 1 to 32, you will have here 33 to 64. Okay, here 33 will beat 64. So who will go forward? 33 plus this would be half of it. So this is 16 will go forward. So 33 to 48 will go forward. Now 33 to 48 go forward. Again, 33 will beat 48, 34 will beat 47 and so on, which means that again 8 go forward. So after this round, if there is no more upset, who is the lowest ranked player who will win? 33 will win. If I have my upset in any of these rounds, I won't get to 33. My only chance of getting the lowest ranked player to actually win this tournament is all the upsets that occur in the first round itself, because then 1 to 32 only get eliminated, and then I am left with 33 to 64 who are the lowest ranked players of the tournament. From then on, even if there is no upset, I get to 33 being the eventual winner, which basically is the lowest possible configuration I can get. So if the player who could have won the tournament, so the lowest seeded player who could have won the tournament in this scenario is option C, 33. I hope everybody understands this one. Okay, so let's go to the second question. The 12 seeded player may face the player of which seed in the third round? So now we are looking at who can possibly play against 12, okay, in this round, third round. So 12 is playing whom? The sum should be equal to 17. So this should be 12 versus 5. We can either have 5 or we can have players who could take the place of 5. Who can take the place of 5? In the first round, who can take the place of 5? The sum should be 65. So instead of 5, we can have 60. If 60 beats 5 in the first round, he takes the position of 5 in all subsequent rounds. So 60 could be one of the players. Okay, this is directly, it is given as the answer. I can directly mark it off. But I want to give the full list of all players who can actually take 5's place. Okay. Secondly, who can actually be taking the place of 5 instead of 60? Who else can take the place of 5? In the second round, suppose upset occurs not in the first round, but in the second round. Who does 5 play against in the second round? Sum has to be 33. He has to play against 28. So instead of 5, you could have 60. You could have 28. In the third round, he's playing against 12. So here, there is no upset over here. The upset has to occur either in the first round or the second round. First round, 60. Second round, 28. But there is one more player who could actually come there with an upset. Because instead of 28, suppose 28 only got upset in the first round, who would come in the place of 28? So 28 plays against whom? 65 minus 28, he plays against 37. So instead of 28 also, I can have 37. So who can take the place of 5 in the third round? 5's place can be taken by 60 if he is upset in the first round. It can be taken by 28 if he is upset in the second round. Or it could be taken by 37 if 37 first upsets 28 and then upsets 5 in the second round. If there are 2 upsets, 37 could also be facing 12 in the third round. So who could be the person 12 player seeded player faces in the third round? Not 23, not 36, not 53. The correct option that we can choose is option D, 60. Okay, anybody has any questions over here? How did you get 48? Where did I get 48? Okay. Upset only counts for the better rank. Upset counts for everybody. You are part of a match which was an upset. If you won against a higher rated player, even that is an upset. Okay. If 60 beats 5 in round 1, did 60 win against 28 in round 2? Yes. 60 would have to beat round 1. Here in its place, he would have come over here, beat 28 or 37, and then come over here. That is one way in which he can come to the third round against 12. So basically, who can take 5's place? So we have to essentially see who can assume 5's identity. Who could have killed 5 in the earlier rounds and taken his identity? His identity could have been taken by 28, or somebody took 28's identity and came over here. Who could have taken 28's identity? 37. Or 5's identity was taken in the first round itself by 60. So all of these are possibilities. These are the 3 people who could have taken 5's identity, and 5 was supposed to play against 12, but instead any of these 3 can possibly play against 12. Okay. Okay, previous question, question 9. How did I get 48? I didn't get 48, I got 33. Option C is the answer. Okay. Okay, so let's go to question 11. If the players who is seeded 38 won the tournament, who among the following could he not have defeated in the quarterfinal? So we have 38 winning the tournament. Okay, who among the following could he not have defeated in the quarterfinal? Where will he come in the quarterfinal? Okay, let's see. 38, the sum of 38. So this should be 27 place 38. Okay, so he will beat 27 in the first round, and he will take 27th place over here. 27 will play against 6. 6 and 27 play against each other. I'll remove this. This is from the earlier question. This sum is 63. So he is going to beat 6 in the second round and come in the place of this. Instead of 27, there will be 38 over here. We need who will he beat among the quarterfinal. So he is now going to take the place of 6. In quarterfinal, who does 6 play? 6 plays 3. So we want to see who could have snatched the identity of 3. Because from this point onwards, we need not do any upsets. We already have 6 in this table. So 6 is going to play 3. Instead of 6, 38 has basically snatched his place. 38 has taken the identity of 6. So 38 is going to play 3 in the quarterfinals. So we want to see who could have actually taken 3's place in the quarterfinals. So who could have taken 3's place? 3 could have lost to 14. So one of these people is 14. And 14 also could have his own identity snatchers. So we have to make that list also, but wait for it. 3 could have lost to 30. But again, 30 also could have his own identity snatchers. Or 3 could have lost to 62. But 62 also could have his own, no, 62 can't have his own identity snatchers because that has to be the very first round. He can't get upset anyway. Okay, so these are the 3 probables in this round, in this round, in this round, who could basically play and take 3 spot. Consider 14. Instead of 14, who could have come? Over here you have 14. Who would 14 play? 14 would play against 19. Sum is 33. So again, instead of 14, you could have 19 in 14's place. Instead of 19, who could come? If instead of 19, we had somebody taking 19's place, this sum is 50, 65, 65 minus 19. We could have 19 place, 56. We could have 56 also come in his place. So this could be 56 also coming in place of 19. Another person, 14, that plays over here, 14, 65, 14 and how much? Sorry, this is not 56, this is 46. This is 65. 19 plus 46 is 65, not 56. This is 46. And instead of 14, 65 minus 14, we could have 51 also. So 14, instead of 14, we could have 19, we could have 46, we could have 51 also, who could have come in the place of 14. Okay. 14 could get upset over here, could get upset over here. 19, 46, done. I think this is the whole list of people who could have come through this 14 path. 30 path. Who could have come in the place of 30? So 30 could have gotten upset in the first round itself, and instead of 30, we could have 30 plays against 35. So instead of 30, we would have 35 also over here. So this is the list who could have come in the place of 3, who could have stolen 3's identity and played against this guy 38 who would play against here. So instead of 6, you have 38 over here, and instead of 3, you have the people who have stolen the identity of 3, and this is the list of all people who could have stolen the identity of 3. So among this, let us see who among the following could he not have defeated. So 11 is not there in the list, 19 is there in the list, 30 is there in the list, 51 is there in the list, 11 is the only one who is not there in the list. So 11 could not have been defeated in the quarterfinal. One more thing that you can see is, see 6. Where does 6 play 11? 6 is supposed to play 11 over here. So 38 takes place of 6. So here 38 is going to play, if 11 reaches the third round, 38 is going to play 11 in the third round itself. He cannot play 11 in the quarterfinal, because if 38 has reached a quarterfinal, he has already defeated 11. He could not possibly meet 11 in the quarterfinal. So the correct option over here is C. Everybody understood this one? Okay, I put that 46. Anybody has any questions with this one now? Oh, how did I get 33 to 48? So basically, I have to get 16 people. So 33 plus 16 minus 1. So I got 48 that way. Okay. So I have to say 33 to 64 go ahead, right? Half of them without an upset, who will lose? 33 to 48. 48 will play 49. 49, 50 till 64. The sum of the numbers, 33, this would be 97. So 48 will play 49. So basically 33 to 48 will go ahead in the next round without an upset. That's how I got that. Okay. Okay. This is for answering Zoheb's question. This is, if somebody is wondering what I'm saying, this is just to answer Zoheb's question, how I got that 48. Okay. So let's go to the question number 12. At least how many upsets are required for a player who is seeded 42 to win the tournament? Okay. For a player seeded 42, what has to happen? Over here, who is he going to play? Over here, let's remove all of this. Who is 42 going to play in the first round? 42, 65 minus 42, I will have, this is equal to 23. So he is going to play against 23 in the first round. So first round, there is one upset. He is going to take the place of 23 over here. Who will he play in the next round? If he has to get a next round win, he is going to play taking the place of 23 over here. 33 minus 23, he is going to play against 10. So he is going to create another upset in the next round. He is going to win against 10. Now you might say, ma'am, 10 might not come. 10 might have gotten upset in the earlier round. But even then, that would count again as one upset only. So it doesn't matter whether 10 got upset here or 10 got upset here. It doesn't matter, because it eventually leads to one additional upset that has to be counted. So here 42 will take the place of 23. He will win against 10, and he's going to take the place of 10 in all the further rounds. Who is going to play 10 over here? 10 will play against, this is 17. So 7 is going to play against 10. So he is going to take 42 instead of 10. You are having 42 over here. Again, you will need one upset before he moves to the next round. So a third upset. Over here, quarterfinal. Quarterfinal, again, he is going to take the place of 7. So 2 is going to play against 42. 2 playing against 42. Again, there is an upset. So he moves on to the semi-final. 4 upsets till now. He is going to take the place of 42 over here. So instead of 2, you will have 42 playing against 3. 42 playing against 3. Again, there is an upset. He moves to the final. Instead, also, again, there is an upset. He moves to the final. Again, he takes the place of 2 only. So 1 plays against 42, again an upset, he wins the final. So how many upsets are needed for 42 to win the tournament? 1, 2, 3, 4, 5, 6. Always remember, if a lower ranked player is moving through, if he is below in the second half, he has to actually upset every single match that is going onwards. So if there are 6 rounds, he has to have 6 upsets. If suppose it is in the first half, okay, it is say 30-second clear. Instead of say 42, 32 was asked, then he would not need upset for the first round, but from the second round onwards, he would need upsets. So if it was 32, he'd need 5 upsets. If it was 16, he would need 4 upsets. If it was like 8, he would need 3 upsets and so on. So depending on where that person lies, he need fewer upsets. It's 1, he needs no upsets. 2, he needs 1 upset. 4, he needs 2 upsets and so on. So you have to basically see in which bracket he is lying. Since 42 is lying in the bottom bracket, he is going to need, since there are 6 rounds, he is going to need 6 upsets before he wins the tournament. So what is the correct answer over here? It is option B, 6. Okay? Okay, guys. I hope all of you guys understood this one. Okay? Anybody who didn't understand any part of the knockout tournament, anything that didn't like click with you, just ask now. And then we'll go to the next type of LRDI set that we are going to learn today, which is scheduling. Okay? Come on, guys. And if you guys have still not liked this stream, please like this stream. It helps us quite a bit in reaching more students. Please like the stream. And if you're looking for a structured way to prepare for CAT, do check out Cracku's Apex batch. It starts Monday. The link is in the chat box. Do check out the batch because we have a discount of 8,000 which is running right now. Tricky set to break. It's not tricky, Rakshit. What it is basically is that either you know and you know how to solve it, or you don't know and then you struggle. I also didn't figure this out by myself. Okay, people have figured this out how to do knockouts out tournaments, and then you know, and then once you know the representation format, it becomes easy. Always remember in LRDI, it's not that you are not smart enough or you don't know. You don't know the right format. The minute you know the right format and you consistently apply the right format, it is not that tricky. You just have to practice knockout tournaments with this format a couple of times, okay? 2-3 sets like that, and then it will click with you, and you will then find all knockout tournaments from that point onwards very simple, okay? So let's go to the scheduling. Anybody has any question, ask me. Do knockout tournaments typically come? What we generally see is if games and tournaments come, we have multi-stage tournaments more often than knockout. Knockout very rarely will come. But what happens in the multi-stage tournaments is that the first is a group stage. There you have to do some group stage enumeration puzzle kind of this. And then then you have like the final 8 have like quarterfinals, semi-finals, finals. That becomes knockout. So then the knockout logic comes into play in the second half of the tournament. So there you need to know you need to know how to actually work the knockout tournament also. Okay, looks like a straightforward set, but needs a first study it in the first place. Okay, that's fine, Zohib. You have to basically practice different types of sets. Okay, so let's go to the next type of set. So after this, we have a LRDI set on scheduling. But before that, a quick reminder to everybody who has not started taking CAT mocks yet. Guys, we see the same mistake appear with students make every single year after year. They don't take enough mocks and they leave mocks till September. Please don't leave mocks till later. Don't think that I'm going to first complete my syllabus. In fact, I always recommend that you start your preparation with the mock. You start your preparation with the 0 prep mock and you take mocks regularly. Don't wait for the entire syllabus to be over. If you guys are just starting out, you want free mocks to begin your preparation, we have 3 free CAT mocks. So do check out our free CAT mocks. I want all of you guys to attempt all 3 free CAT mocks. They're free. That's definitely a resource you should use. We also have previous year's papers in mock format. So 2025, there are 3 slots. So that is 3 mocks from 2025, 3 mocks from 2023, 3 mocks from 2024. So all the previous year mock question papers are also in mock format. So they are additional mocks that you can take. See, ideally, you should take around something like 40 mocks. We have dash cats, which are 20 mocks, plus 5 head starts, so that is 25, plus 15 sectionals for each of the sections, so that's 40. Plus, we have like tremendous number of previous year's papers that you can take in mock format, plus the 3 free CAT mocks. So you have basically like you can easily do up to 60 mocks as such. And the more the number of mocks that you do, right, the better your chance of holding your nerve on the actual exam day, the more exam prepared you are. A lot of CAT, doing well in CAT is not just about preparation, but also having the stamina and also having the composure. And composure comes from mocks. So if you haven't started on mocks, please start today. Please take a free CAT mock. Okay. So this is a set on scheduling. But just a quick reminder for those who don't know what is scheduling or how to approach scheduling, I'll quickly tell you the representation format for scheduling. In scheduling, what you have to do is basically make horizontal rows for time. So suppose something is done over say 4 hours. So I'll say at 9 a.m. Okay, 9 a.m. This is 10 a.m. This is 11 a.m. 12 a.m. 1 p.m. So the rows represent the time blocks. So if this is the case, this one time block is 9 to 10. So suppose you have X machines, okay? You have say 3 machines, say A, B, C. So for the machines, I will put a column for each machine, okay? So say the machines are A, B, C. I put a row for each of the time periods that are there. I put a column for each of the machine, each of the people, whatever is the person who is doing the work, you put a column for it, you put a row for the time that is there. Now, how do you use this scheduling thing? You have to essentially fill the schedule. So if I tell you that a person X works on machine A from 9 to 9:30, then you have to say that, okay, I'll fill this halfway and I'll say X is working here from 9 to 9:30. So I have to visually represent scheduling information in this format. If I say B works or say Y works on machine B from 10 to 11. 10 to 11 is from this period to this period. So Y works on this machine from 10 to 11. I'll mark it off. So whatever is the time, I basically represent like this. The machines I represent like this. And whatever information is given, I try to fill it and show what is going on. Scheduling is solved through drawing it out, through visual representation. This is the representation format. Vertically time, like basically you will be given lined notebooks, right? Use the lines of the notebooks to form the vertical timeline chart. And for each machine or each person that is working, draw a vertical column for it and keep filling it. Basically draw it out. If it is half an hour, draw a middle line and then show it. If it is quarter of an hour, draw like 1/4 and fill it. Whatever is needed, show visually, because then it becomes easy for you to understand what is going on. Okay, always try to represent the information in these blocks like this, so you can see that, okay, this work can happen in parallel. This work will happen one after the other. Draw it out, fill this table till you get the final answer. This is basically the representation format for scheduling. If you remember this representation format, scheduling becomes super easy to do. Okay, so with this, I'll give you this set to do. Okay, this is the set. The time starts now. I'll after you guys are done reading, I'll go to the bottom part of it. So Shruti is asking, what are the top 5 sets for DILR must-do types? Puzzles, enumeration puzzles, quant puzzles, Einstein's puzzles, arrangement, so linear arrangement, circular arrangement, tables, table with missing values, charts, pie chart, bar chart, line chart, radar chart, all charts as such. These 4 are the most important types. After that, this is like the most commonly asked. The second most commonly asked are games and tournaments, scheduling, routes and networks, and 2D LR puzzles. All of these are second order sets. Then the third order sets are team selection, truth lie kind of sets, which are basically very, very rare as such, but have come at some point of time in the past, so we still cover them. But these are rare sets. But the most common sets are puzzles, arrangements, tables, charts. Okay, make sure that those are always done. Okay, this I will go to the end of this. This is the table. And this is lastly the additional information. The questions are, this is question 13. This is question 14. 15, and 16. Okay. So you guys, your time has started. Try to solve all of these questions. Okay, Vardhan. Vardhan Yash, see, 77, 97, 95, 89, 17 months of work You have an excellent profile, Vardhan. Just make sure that you focus on getting a like very good CAT score because you are I'm assuming you're a gem. Even with a very very good profile, you still need 99.7 at least. Okay, so make sure that you try to get as high a score as possible in CAT. You have 9, 9, and 8 profile, excellent profile. You just need a good CAT score and you will get ABC also. So try to focus on getting a like 99.8, 99.75 at least, and then you have a very good chance of getting ABC shortlist. It's slightly over here. There is another point so that you guys can see that. Zoheb, I would say that if possible, continue working. A gap in your career is never a good thing. Uh, you already have 30 months of work experience, so you need not worry that much about a gap year because a gap year is more hurts you more during your interviews if you have had no work experience. After 30 months, they'll be kind of soft on you even if you have a gap year. But I would always say no gap year is better than a gap year. So if you can manage your preparation with working, always better to do that way. Okay. You guys haven't answered question number 13 though. What is 13? And this is 15 and 16. Okay, guys, last 2 minutes left. Come on, I want everyone to try to solve it. It's not a tough set. We can solve this set. Fifteenth answer is A, not option. A is option B, so it is there. Akash, your profile is average profile, neither too good nor bad, but you need work experience. See, an 877 is an okay profile. There is no big weakness in your profile because sevens are kind of average as such. But you need more work experience because if you have work experience, you can get a fairly like you get points from there, and then your profile will be slightly on the better side. Right now with commerce you have non-engineering academic diversity points also. If you get some work experience, it would actually help you quite a bit in like being able to even convert the calls is also important. So if you have some work experience, you have something to talk about during the interview, and that also will help you a bit in converting the calls. So I would say that if you guys are currently not working, please try to get a job, because having work experience makes converting calls much easier, because they will ask you more about your work experience, where you can answer questions much more easily as compared to your acads, because in acads they can ask you a lot of things, and it would be tougher to actually defend acads rather than work experience. So if you guys are not currently working, try to get a job where you get at least like 2-3 hours every single day to prepare for CAT. That is enough to really crack CAT. Okay. So many of you have tried to solve this one. The time is up. So let's try to solve this particular question. I saw some options where the answers were kind of weird. So let us see how to solve this one. Okay. So as I mentioned in scheduling, you have to draw a table. We have to have like time period should be rows, and the machines or people who are working should be columns. So let us see the question that is given. 4 people ABCD visit a gym, and that has 5 exercise machines, PQRST. The gym opens at 12 o'clock and closes at 5 o'clock. So what would be the time periods that we have to consider? We have to consider the 5 hours that are from 12 to 5. So 2, 3, 4 and 5. Okay, this is the time period that we have to consider. There are 4 people and 5 machines. So should I make 5 columns for the machines or 4 people for the machines? See, each person is going to a machine to work out. So rather than putting that, okay, this person in the column, I should put machine so that I can say that first A comes to this machine, then B comes to the machine. Secondly, the reason to choose machine instead of people is that the information that is given in the table, okay, this information is given for machines, it is not given for people. Who is the first user, who is the last user is given for machines. Which machine that user goes to first is not given. So because the information is more aligned to exercise machines, I will put machines as the column. So we have 5 machines, 1, 2, 3, 4 and 5. These are P, Q, R, S, T, and this is from 12, 1 o'clock, 2 o'clock, 3 o'clock, 4 o'clock, 5 o'clock when the gym closes. So this is the information that is given to us. Let us go back to the initial information. This is a table that I have to fill. I have made the table. Okay. So everyone has to follow the following rules. Each exercise session on a machine lasts exactly 1 hour. So if I put one person, it is going to be in 1 hour blocks. I'm not going to do half an hour. All of that cutting of blocks is not required. Each person is going to go and take a full block only directly. Okay. Only one person can use a machine at a time. So there is no cutting of the blocks. So essentially, if I say that A is working on machine P from 12 to 1, only A will be here. So it essentially becomes that I don't have to draw anything. I just have to put the right person value over here. So that is one thing that I can infer from this. A person cannot use the same machine more than once. So essentially, in this particular column, a person's name will appear uniquely exactly once, because one person works exactly for 1 hour. So it will appear in this column exactly once. Okay. A person may rest between exercises for an integral number of hours. So again, they will not go to another machine in between the hours as such. So they will either start at like 12, 1, 2, 3 or 4. They are not going to go at 1:30. That is not a possibility. Whenever a person starts an exercise session, they use exactly one machine. So again, essentially row-wise, column-wise, it has to be unique. Row-wise also unique. You can't be at 2 machines at the same time. If a person arrives at the gym, they start their first exercise immediately. So no waiting before the first session. So if I come at a particular time, I'm going to start my workout immediately. I can take rest after starting my workout. So there can be gap between my first workout and my second workout. But there should be no gap between me coming to the gym and starting workout. So this is one clue that I have to remember. Otherwise, the other clues essentially mean that there has to be column-wise unique, row-wise unique. There should be no repetition in column, no repetition in row. In one block, there should be only one person. That is what I have to remember. So we have been told, okay, in exercise machine P, the first user is D and the last user is C, and 4 people use the machine. There are only 4 people, A, B, C, D. So machine P should have A, B, C, D, and D should be the first person, C should be the last person. A and B will be there in the middle in some particular order. Q has 2 people, C and B. And only 2 people use the machine. First user is C, last user is B. So So only C and B should come over here, nobody else. R has A and C, only these two people. So A and C should be the only users, no B and D over here. S has only two people, B, C. So, and that should be B first and C next. And T has also only B, C, so B first and C next. So I can see, I at least know who is coming how many times in this particular, who is working out how many hours in this gym. A comes 1, 2. So A is going to work out for 2 hours. B, how many times does B come? 1, 2, 3, 4. So B is going to work out for 4 hours. C, 1, 2, 3, 4, 5. So he works out from 12 to 5. He's working out all the time. He works out for all the 5 hours. So C works out for 5 hours. All the 5 hours he's working out. D, he works out only once. So D is essentially the laziest. He's only working for 1 hour and then he's going off. Okay. So this is the information that I know about people who, how much time they are working out. This is also important information for me to tabulate. Okay. Now additional information is given. The additional information is A arrives at 1 o'clock and begins exercising on machine P. So A is over here and he has to basically immediately start exercising. B, C and D arrive at 12 p.m. There is no waiting before the first session, which means that B, C and D have to start immediately over here. They have to be in this row. It cannot be that they are not in this row. Okay. The second thing is B takes a lunch break from 2 to 3 p.m. We know that B works for 4 hours. He does not work from 2 to 3 p.m. So for every other hour, so 12 to 1 he is there, 1 to 2 he is there, 2 to 3 he is taking a break, 3 to 4 he will be there, and 4 to 5 also he is working. C is working all the time. C is there every hour. So C is here, C is here, C is here, C is here. A is working over here and A is working for 1 more hour. We don't know where, so we don't know where exactly A is working. But over here we can say that A is working at least 1 hour, and between these he cannot be working over here because he comes at 1 o'clock. So A will come either here, here or here. Okay. D is only working for 1 hour and that is at 12 o'clock, 12 to 1. So D will never come in any of the other rows. Where is D coming? Essentially D is coming at 12 o'clock. Which machine is he using? The first user to use P is D. So before A, D has to use it. So D has to come over here. I have marked off all of D's entries so I can forget about him because D's entry is done. The only thing that I have not marked till now is A's second work hour because it has to be between somewhere over here 2 p.m. to 3 p.m., 3 p.m. to 4 p.m. or 4 p.m. to 5 p.m. I don't know for sure, but he has to work somewhere over there. Okay. Now consider what other information is given. So D is the first user, C is the last user of this machine. Now over here, C is the last user of many machines. C has to be after B. So B can be here, C can be here, or B can be here, C can be here. Okay. We have the option that since C is the last user, right? C has to come after B. So we can have BC like this, or we can have BC like this. But B doesn't work from 2 to 3 p.m., which means that he can only work from 3 to 4 p.m. So therefore, C has to be over here 4 to 5 p.m. This PM is basically no one is using machine P. Okay. So I have used up, I have marked off this also. I have marked off this. I have marked off this. Okay. C, I have marked off this also. Okay. I have to put A somewhere over there. That is something that I have to keep in mind. But at least the machine P is completely done. I have marked off everybody for machine P. So that way one thing is done. Okay. Consider machine Q. C and B. C is the first user for machine Q. For everything else, C doesn't start the machine. But C has arrived at 12 o'clock, which means that he must start working on some machine. In R, he does not work at 12 o'clock. In S, he does not work at 12 o'clock. T does not work at 12 o'clock. Because if he had started working at 12 o'clock, he'd be the first user. So the machine that C starts working on is Q machine. So he's going to start with C. We are left with multiple alternators for B. B can be here. B cannot be here because B is essentially not working from 2 to 3. B cannot be over here because he's working on this machine. B can be here also. So that is one thing that I have to consider. Okay. Now, B could be here. We don't know whether B is here. B is there because B is essentially working for 4 hours. Okay. So that is the possibility. These are the possibilities for B. It is either here or here that B could be on machine Q. Let us see the remaining machines. R is on A and C. R, the first person using is A, and the last person using is C. A cannot come over here because he comes at 1 o'clock only. So because of that, he cannot come over here. Here he is already machine Q, so he cannot come over here. We can have A and C over here, so we can have A over here and C over here, or we can have AC over here, A over here, C over here. But if we have the second configuration, right, what happens? This C and this C will conflict. So therefore, I can say that this cannot be the configuration. We have to have C over here, A over here. So this is basically how our machine is used. Here A has not arrived yet. Here A is on machine P, so it cannot be used. If I put A, C over here, 3 and 5, 3 to 5, then C will be on 2 machines in 4 to 5 period. So this is the only configuration that is possible. This is also done. Now let us consider, we have A's, okay, so A's 2 R's are also done. So this is the second R for A, done already. Now consider S. S is B and C, and T is also B and C in some order. Okay, so we have to have a block of B and C, and that has to be basically one person has to start at 12 o'clock. See over here, B has arrived at 12 o'clock. Either he will start with S and work over here, B will work here, C will work here, or he will start with T, B will work here, C will work here. There are essentially 2 options that we have for when B can work. And it need not even be contiguous, but let us see where C can possibly work. C has to be there once in each column and once in each row. He is working for all 5 hours and he is basically there in all 5 machines. So here he has to appear once in every single row. This row is done, this row is done, this row is left, this row is left. So here we have 2 possibilities, okay? C can come over here. So we can have that this is B and this is C, or we can have this is B and this is C, okay? We can have this as the possibility. B first works on S, then goes to T, and C then works on S and then goes to T, because B has to come first, C has to come next according to this table. This is one possibility. Or the second possibility is that B works on S second and B works on T first. So we can have BC over here and nothing over here, or we can have BC working over here and then BC working over here, or we have BC working over here and then this. So these are the 2 possibilities that we have for in what order B and C can use S and T. BC can use S first and then C first, then T next, or they can use T first and then S next. So these are 2 equivalent possibilities, because see, B and C both are using, only these 2 are left and they have to be in these 3 these 3 rows only. C's this row is over, C's this row is over. He cannot come down anymore. The only 2 rows for C left are, this first row is also over. C is left only in these 2 rows. So it can be either S machine or T machine, and we get 2 possibilities as such. So this is basically in what order we can have S and T in either order. They are equivalent, we can't differentiate between them. So we get that, okay, this is entirely done. This is entirely done. We get 2 possible cases for that. The only one which is not done yet is Q. Q, we need B to work for every hour other than 2 and 3. So B is working 1 hour over here, either on S or on T, and the next hour over here, correspondingly, if he works on S, then he works on T over here. If it works on T, he works on S over here. This 2 to 3 period, he is not working. This 3 to 4 period, he is already working on machine P, which means that only 1 period is left for B, which is 4 to 5. And therefore, he has to work over here. Between 4 to 5, he has to work on machine Q. So this also I have been able to put. This is all done for me, which means that this machine is also done. This machine is also done. From this period onwards, nobody is working on these machines, because it is either BC over here and BC over here, or it is BC over here, BC over here. This is the 2 possibilities, 2 blocks that are there. This is 1 block or this is second block. Okay. These are 2 equivalent possibilities. I cannot distinguish between them because no additional information is given. If I have some information that S comes first or T comes first, then I can distinguish between S and T. But no information is given. Both equal information is given for both of them. So both have 2 possibilities. Okay. So now we can go to our final list. If anybody has any question about this, how I filled this particular table, just let me know now. But B arrived at 12. B arrived at 12, and where did he go? He either went to S and then to T, or he went to T and then to S. Okay? Okay. Anybody has any question till now? Okay, I'll go and answer the question. So how many possibilities or how many distinct arrangements that we get? We get 2 distinct arrangements because of the order of SNT. So the 2 possibilities are there. If B started exercising using machine S first when he came to the gym at 12 o'clock, then who was using machine T from 2 to 3 p.m.? So we are looking at the first configuration, this configuration. So we have to look at who was using machine T from 2 to 3 p.m. 2 to 3 p.m. we have C, okay? C was using machine T from 2 to 3 p.m. So the correct option to choose is option A. Who was using machine R from 2 to 3 p.m.? R from 2 to 3 p.m. A was using the machine R from 2 to 3 p.m. And last question, who was using machine S when A was using machine P? When A was using machine P, we can have S used either by C in the first scenario or by B in the second scenario. Unless extra information is given, I cannot determine who was using it. Either B or C could be using it. So the correct option to choose is option D, cannot be determined. Okay. Anybody who could not understand this or could not understand how I made the table. See, in making this table, I wrote down in row who should appear. I wrote in the row who should appear, in the column who should appear, how many appearances each one of them should have. That helped me quite a bit in figuring out, okay, between this, how many chances or how many gaps have to come, how many people I have to fit in a particular column. All of that helps me fill a column, and the row information helps me fill the row. Again, whenever I get that, okay, I can't differentiate, I make cases. So this you have to always consider that write the row information right at the end of the row. Write the column information at the bottom. So then you can fill backwards. Anybody who didn't understand any part of this, just ask me now. This is the last set that we are solving. So if you guys were able to understand this, if you guys were able to understand how to do scheduling, how to represent scheduling, then this is basically excellent work from all of you guys. If you guys have any doubt, ask me now. And this is the last set, so we'll be ending the session soon. Is it CAT level question, ma'am? Yes. This is something which is, I would expect to come in CAT 2024, questions of this level came. CAT 2025, you will expect this plus some more additional, this will be given. But in CAT 2024, exactly this level of questions came. It was slightly easier, but CAT itself has varying difficulty level. Okay. Okay, guys. Thank you, guys. And best of luck for your preparation. Now that you have done, I think, arrangement, you have done table-based sets, you have done scheduling, you have done games and tournaments. I want you guys to practice a lot of sets. The more different types of sets you practice, the better it is going to be. And again, also try to do many questions from Quant Rush. One last reminder, what we have recently decided to do is basically give money back to all the students who perform very well in CAT. So if you are somebody who is looking for a CAT course and who is worried about, okay, I just want a little bit of help, I'm already doing well, you can check out our Cracku's CAT course. If you get above 99.9 percentile, we'll give you 100% of your money back. If you get above 99 percentile, we'll give you 50% of your money back. So if you are somebody who is very hardworking, who is very committed, this is a way of getting a very good CAT course for almost free or exactly free. If you get 99.9 percentile, you will get all your money back and you can get essentially excellent CAT education for free. If you get even 99 percentile, you will get half of your money back. So do check out our Apex batch. It starts tomorrow and I hope to see most of you or many of you there tomorrow. Okay. Okay. Ma'am, just wanted to ask about 656 non-engineer SE category and currently working as founder's office in startup with 6 months of work experience. Any chance of Blackie? You have a decent chance of Blackie, but Mayur, you need to get a decent CAT score. You don't even need to go to 99.5 plus. Even if you hit 99 percentile, it would be enough. The only thing is that because you have 6s and 5s in your profile, you need to hit 98.5 plus at least. You have ST on your side, so that is always a good thing. You have some work experience, but because it's in a startup, I would warn you, your work experience will only be counted for at least the top IMs if you have PF contributions. So if you are not contributing to PF already, please try to get into the PF program, because those are another check that these guys are using, especially for startups and all. They are trying to actually check whether you were actually working by seeing whether your PF contributions were there or not. Okay, that is the only warning. But otherwise, you have a fairly good chance. Just get 98 percentile above. You should be fairly good. You will get all ABC calls also. 998 OBC BA. Getting BA economics for 2 years gap. Is it worth getting a job anymore? Because I have to work on quant basics as well as DILR. Your profile is very good, Mahzoom. I would say that if you have non-engineer 998, if you have some work experience, that would be good. See, I don't think the work experience will help you in getting the call, because the number of, like, you'll get 6 months of work experience, you'll not get much points for that. But in converting that call, it will make a huge difference. So if you have, I would say that if you want to, at least try to get a job around September, October, so that once CAT is done, you can focus on the job, and you will have something to talk about in the interview process also. In the interview process, they will otherwise ask you mostly about your 2 years gap, and you will be on a psychological back foot because of it. So instead of having that kind of conversation, you would rather have a conversation about the job you're currently doing. So if you can't get a job right now, I would say start applying at least, so that you get something which is joining a bit later on. And definitely try to get a job after November, because you don't want to go into the interview with no job in hand. Okay. How often can we expect a set coming on passwords in CAT? It came, I think, in 2021 or so. It can come. Again, see, I'll tell you, okay, the highest frequency sets are puzzles, arrangements, tables, charts. Everything else is lower frequency. Scheduling comes more often. Games and tournaments comes more often. 2D LR puzzles come quite often. These are the second priority list in the type of sets that come. The lower priority list is team selection, passwords, cubes, 3D puzzles, like all those other random puzzles are like the lowest probability. They will come once every 3-4 years. So you can't really predict it will come. But I would always say that instead of betting on those smaller sets to coming, like 4 sets that always come every single year, every single set. Puzzles, arrangements, tables, charts come every year, every single slot. So I would always say that make sure that you're an expert in those things, because you're going to do 2 sets, 3 sets maximum. Those 2-3 should be from the puzzles, tables, charts, arrangements. Okay. Would you think that 2026 CAT will be tougher or easier than 2025? I will say that, see, I'll tell you what has happened. In CAT 2023, the paper setter made a mistake of making it too tough. Okay, they made it so tough that I think it affected the admission rates. It affected the mix of the students that they got. Then in 2024, they overcorrected and made a very easy paper. That also is not very good. You need like a golden mean, neither too tough nor too difficult. In 2025, I felt that they achieved the golden mean as such. It was neither too difficult like 2023, nor too easy like 2024. This CAT 2025 paper is the exact type of paper that we would get earlier. So I expect something like that to happen, but you never know. Some paper setters don't understand the difficulty of the paper that they have set. So sometimes they make a mistake of either setting a very difficult paper or a very easy paper. But I think they are always striving for that golden mean, neither too tough nor too easy. Okay, so with this, we'll end today's session. And best of luck to all the guys who are preparing. Do check out our Apex batch, which starts on Monday. And do check out Quant Rush. I want you guys to solve as many questions as possible, as many sets as possible. So good evening, guys, and goodbye for now. And we'll see you next Saturday.